today we are going to be factoring to solve some equations. Now I've changed the directions to solve rather than just factor here, so we can practice that concept. And so the first step we're going to end up doing is looking at this last digit sign. And whenever that's negative, that tells us that the outside and inside terms are subtracting. And what we'll end up with is a negative 11. So we'll go ahead and draw two sets of parentheses and think of some numbers that make 6n squared. Well, numbers that make that are 3n and 2n. So we go ahead and now try some numbers that make 10. And so again, if this doesn't work, then I can go to 6n and 1n. But I'll just try this to start with. Let's just go ahead and try a 5 here and a 2 here and see if it works. And so I'm checking these outside-inside terms to see if they subtract to make 11. Well, this is 4, and this is 15, and they will subtract to make 11. Now, to make a negative 11, we make the 15 negative. So put the minus sign here and the plus sign here. And so from that point, we have to take our factors and set them equal to 0. And so when we do that, we'll end up with two distinct answers, two values for n that make this equal 0. So let's take a look at one of those here. And so here I'm going to end up subtracting this 2 from both sides. And when I do that, I have this 3n equals negative 2. Then I divide by 3, and I end up with n as negative 2/3. Over here I have to end up adding this 5 to both sides, and so I end up with this 2n equals 5. Divide by 2, and we end up with n as 5/2. And so those are our two solutions, or two roots. They also call them zeros, different ways of representing the same answer there. So negative 2/3 and 5/2. Well, taking a look at this next one, here we have a prime number, so that's the number that we're going to start with. We also know that the outside and inside terms this time are going to end up adding together because they're the same sign. They will add to make a positive 9. So we start off with 5x and x, and then we just try different numbers that make 4. Now, as I look at it, 5 times by 4 would make 20. 5 times by 2 makes 10. So I need these numbers to add to make 9. So I can't multiply 5 by a number to make it bigger than 9. So it's got to be a 1 there and a 4 here. Both plus signs, and let's see if it works. See, this makes 5x. Here we have 4x, and that adds to make the 9x. So it does end up working. So once you're confident you've got the factoring done right, then what we're going to do is set the factors equal to 0. It's called the zero product property. It says that whenever you multiply a number by 0, you get 0. So if we go ahead and set the factors equal to 0, we're going to find out the value of x that makes that the case. So we do this, and we got a 5x equals negative 4. Divide by 5, you got negative 4/5. Over on this side, you'll subtract the 1 from both sides, and you get x as negative 1. So there it is. Negative 4/5 is one of the solutions, and negative 1 is the other. So this is just one minus sign here. So let's take a look at our next problem. Again, we have a prime number, so we always start with that prime number. This time's a little different because we're starting with the last term rather than the first and trying to figure out what the first terms are. Well, the outside and inside terms are subtracting to make the 4x. So we go ahead and try some different numbers here. We start with the 3 and the 1 this time. We know they subtract to make 4, so I don't want to multiply 3 by 5 because that's going to make something too big. So if I try a 3 times by 4, or I'm sorry, 3 times by 3, that makes 9. That's bigger than 4, and that's okay. And if I put the 5 here, I think this will end up working out. So let's try this. So this is a 3 here. And so let's check our numbers here. So this makes 9x. And here the outside terms are multiplying. They make 5x. Put the x right there next to the 5. And we can get those to subtract to make 4. Now to make it a positive 4, we need to make the 5 negative. So put the minus sign there, plus sign here. So now we know that the factoring is done right. So let's go ahead and set those factors equal to 0. And so when we do that, we'll have two different answers here. We'll go ahead and subtract the 3 first. And over here, we're going to end up adding the 1. So on this side, we've got 5x equals negative 3. Divide by 5, and that's how we get negative 3/5. On the other side, we have to add the 1. So we got 3x equals 1. And so you divide by 3, you got x equals 1/3. So there it is, negative 3/5 and 1/3 is the answer there. Alright, so on this next one, we're going to go ahead and take a look at our sign of that last term, and it's a positive here, and that tells us that we have to add the outside and inside terms, and when we add those together, we end up with 22x. So since 5 is a prime number, we're going to start with that as our first two terms that we'll put inside the parentheses. 1 times 5 are the only numbers that multiply to make 5. We also know the signs. Both have to be positive signs there, and so what we want to do now is multiply 5 by a number that's going to make something pretty close to 22, but not too far off. And so if we do a 4x times by 5, that gives us 20. That's pretty close to 22. And so you see 4 times 2x, 4x times 2x makes it 8x squared, and we'll just end up multiplying the 1 and 2 to make 2, and that does add to make 22. So now we've got the factored form right. We're confident about that, so we take those two factors and set them equal to 0. Come up with our two solutions, two roots, two x-intercepts. So we'll go ahead and subtract that 1 from both sides, and we now have this 4x equals negative 1. On this side, we'll subtract that 5 from both sides. So we got this 2x equals negative 5. So we go ahead and divide by 4 on this left-hand side here. So x is negative 1/4. On the right side, have to divide by the 2. So we end up with x as negative 5 halves. So those are the two solutions. Again, these are x-intercepts. They're where the graph crosses the x-axis. The values of x when y equals 0 is another way to represent that. Well, let's take a look at our second to last one here. We have a plus sign. It tells us that we are going to add the outside-inside terms, but this time when they add to make a negative. So that tells us something about the signs that go inside the parentheses. We know they're both negative. The other thing we know is that we shouldn't use 6, because 6 times a number is going to give us something bigger than 13 unless we multiply it by 1. So, or even 2. If we do 2 times 6, that'll give us 12, but the next set of factors would end up giving us something bigger than 13. That'd add to make something bigger than 13. So I'm going to go with a 2x and a 3x for numbers. Actually, instead of x's, let's use n's there. And so we'll go with 2n and 3n for the numbers that make the 6n squared. And to make this other 6, though, I don't want to multiply 2 by something too big. So let's try multiplying it by a 2. And let's put a 3 here and see if this works out. Remember, we're adding these numbers. This makes a negative 9n. Here we have a negative 4n. And those do add to make negative 13n. So we got the factored form right. So now we just have to find the two values of n. So we go ahead and set up our two equations here and add the 3 to both sides on this one. And then we have 2n equals 3. Divide by 2. We've got ourselves n equals 3 halves. On this other side, we're going to end up adding 2 to both sides. We've got 3n equals 2. Divide by 3. We've got ourselves a fraction this time, 2/3. So the number on the bottom is a little bigger, so that means it's smaller than 1. So we got ourselves 3 halves and 2/3. Those are the two x-intercepts, two roots, two solutions. Lots of ways to represent that answer. Last one here has a negative sign in front of that 18. That tells us that the outside and inside terms subtract this time. Subtract to make 9x. And so since we have a prime number, that's where I'm going to start. I'm going to start with my 5x and x this time. That makes the 5x squared. Now I just need to think of numbers that make 18. So when I do that, I want 5 to multiply by something that makes it just a little bigger than 9, but not too much bigger. So I'm going to try multiplying 5 by a 3. So 5 times 3 is going to give me 15. So I need another factor of 3, or a factor of 18, that when I multiply it by 3, I get 18. So that'd be 6. So let's see if this works. So 6... when I take that away from 15, I do get 9. So that does end up working out. So in order to get a positive 9, though, I have to make the 15 positive and the 6 negative. So that's where my negative sign goes, and plus sign. And then I go ahead and take my two factors and set them equal to 0. So when I do that, I've got to add this 6 to both sides. I get this 5x equals 6. Divide by 5, and I got x is 6/5. That's one answer. Over here, we just have to subtract the 3. And when I do that, I get x as negative 3. So there are the two answers, 6/5 and negative 3, the two x-intercepts. So those are the types of problems that you'll see on tonight's homework. So again, remember to change those directions to solve rather than just factor. So you're going to factor first, then solve. Good luck on tonight's homework.